The next Action Hub event will be starting in 5 minutes. Please make your way to your seats. We would like to remind you not to move furniture and respect social distancing at all times. The next Action Hub event will be starting in 1 minute. Please take your seat and switch your phone to silent. If you don't have a seat, we invite you to watch the event online on the UNFCCC website or on the COP platform, but please do not stand on the side of the Action Hub.
Ladies and gentlemen, welcome. My name is Eliot Whittington. I'm Director of Policy and Industrial Transformation at the Cambridge Institute for Sustainability Leadership. And I'm very pleased to welcome both our audience here in the room and our virtual audience to a discussion about the development of Cambridge University's Aviation Impact Accelerator and how to work on the system challenge of decarbonising aviation. I'm very honoured to be joined by two guests. So Rob Miller, who leads the Aviation Impact Accelerator, is Professor of Engineering and Aerodynamics and Director of the Whittle Laboratory in Cambridge University, which is a global centre of excellence. And John Holland-Kaye, the Chief Executive of Heathrow Airport, the largest airport in the UK, and a global transport hub, but also a huge champion of this effort to create change and shift in the industry. So we're going to have a little bit of a conversation about some of the challenges in terms of, and the opportunities in terms of what's facing the sector and how to move that forward. And then we'll hear a little bit about the plan in terms of the Aviation Impact Accelerator. And I'd love to take questions whether from the virtual audience or in the room. So if you do listen out, if you have things to say, please do be willing to come forward with those questions. So I wanted to start by just kind of really establishing, what it is that we're trying to resolve. So, obviously aviation is 2% of global emissions, but it's a sector that we talk about a lot. It's a sector where we're very aware of it as a challenge in terms of dealing with climate change. It's one of those kind of flagships, those very visible signals about what needs to happen. It's 2% of global emissions. Then are we taking it? Should we be taking it seriously? Should we be focusing elsewhere? What do you think, Rob?
Well, I mean, it's 2% of CO2 emissions, 2 to 3% of CO2 emissions, but a single economy ticket from London to New York produces 968 kilograms of CO2, which is more CO2 than many people in Africa, Asia, or South America produce in an entire year. So it is a problem that needs to be addressed. It's very carbon intensive.
Yeah, and if you asked me that question probably 7 years ago when I started in this job, I'd have probably said it's only 2%. And look at all the things we're doing to minimise the growth of aviation emissions. And then actually it was after coming to the Cambridge Institute of Sustainability Leadership, the scales fell away from my eyes, and I realised we've got to play our part in tackling this issue. Otherwise, everyone else will have decarbonised, and we will still be putting carbon into the atmosphere. And it may be less than it would have been, but that's not good enough. We've got to play our part. And if we don't, then we risk losing the benefits of aviation, which are enormous, because we're not prepared to take the steps that we need to take to decarbonise. And we can decarbonise. It's not easy, but we can decarbonise. But we have to change the entire global system in order to do that, and that's what we've set out to do.
I mean, some people would say that the answer is simple. It's just fly less. What would you say to that?
Well, we can fly less. Everyone can make that choice, but I don't think that's going to have any impact on people in China or India or Africa or the Americas who haven't flown enough yet, in their view. Aviation is one of the catalysts for economic growth. It rises people out of poverty. People are still going to want to fly. So anything that we do in Western Europe won't stop people flying elsewhere. And we need to have a much more democratic and just approach which allows us to keep the benefits of aviation without producing fossil fuel carbon, or without using fossil fuel carbon. And if we can do that, then future generations will still have the economic benefits and the personal joy of flying, which is a wonderful thing. And so that's our job to do, to take the carbon out of flying.
Rob, John's very clearly set out how this is a problem we can solve. It's technically doable. Is it just a technical problem? Is there a single, simple answer? How would you see, you're a technical expert, what would you see as kind of like the dimensions of solving that problem?
So, I mean, there isn't a silver bullet. It's a hard sector to decarbonise. It's probably the hardest sector. And there are a number of solutions, all of which we have to do. So sustainable aviation fuels, either where you use biofuels or where you pull carbon out of the atmosphere with direct air capture. You do electrolysis of water, and you put the hydrogen and carbon together with the Fischer-Tropsch process to make a fuel and put it in an existing plane. They're very attractive solutions. There's also hydrogen as a potential vector, which is incredibly attractive, and battery electric at shorter range. But making a decision between these technologies is incredibly difficult. And it's not just a technical problem. It's a policy problem, it's a business problem, it's an economic problem. And therefore, unless you take a whole systems approach, evidence-based approach, the chance of accelerating this process is probably going to be limited.
And I think there are lots of things we have to do, and we have to do them on a global scale because it's a global sector. None of that is easy. But compared to a lot of other sectors, it is relatively easy. We've got an industry which wants to decarbonize throughout the entire value chain. We need to do all the technical things, developing the new planes for hydrogen and battery power, changing airspace. But if there's one thing we need to do, it's develop sustainable aviation fuels, as you mentioned. And that, at least, is easier than many other sectors because that change in the fuel that we use on the existing planes, which can be blended with kerosene, is incredibly powerful. It means that you can have a plane flying from Heathrow powered by sustainable aviation fuel. The return journey can be powered by kerosene if the airport you're going to doesn't have any SAF supply. That doesn't work with hydrogen and battery electric. You have to have charging facilities or refueling facilities at each of those locations. You've got to change the entire plane as well. So if we had to change the entire global aviation fleet, that would be a challenge I think even I might be daunted by. But changing the fuel we use, that is something we can do.
And do you see that as something that the business community involved in aviation has the appetite to do, and how do you think that's changed over the last few years?
Oh, completely. And when I started on this journey, there were very few of us who would put our hands up and say we need to decarbonize global aviation. Most people were comfortable with the industry consensus, which was for halving the emissions from aviation. Now the consensus is we need to decarbonize. IATA, ACI, the Airport Industry Association, they've all committed to decarbonisation. The energy companies are coming on board. The manufacturers are completely on board. So the system has signed up to this, and now the investors have signed up to it too. And that makes it all possible from a private sector point of view. What we need are the policies in place from governments to make it easy for us to do that.
So I think it's great, and actually what we've seen is that growth of new partnerships, new activities, and we're all privileged enough to be involved in a conversation with the Prince of Wales a couple of years ago, which was talking about how to solve some of these systemic challenges. And one of the kind of things that came out of that was the need for additional evidence, which is one of the reasons that we put together the Aviation Impact Accelerator. Before we hear from Rob about what the Aviation Impact Accelerator is and what it's trying to do, John, could you tell us about the kind of evidence, why you think that evidence is so important to industry?
Yeah, so two years ago when we pulled together some of the people from aviation, from manufacturers, energy companies, academics, to start thinking about how do you tackle decarbonising global aviation. And there were lots of ideas and vested interests, lots of people who would say, yes, you can do this, but it's going to take too long. And we needed an evidence base that would say, well, how would you do it? Can we bring people together behind a single plan? And how could we do it quicker? Because we have most sectors where historically you've changed the complete energy supply, it's taken 50 or 60 years to go from coal to gas or oil. We need to go from fossil fuels to sustainable aviation fuels and electric and hydrogen in 30 years. So we've got to really move fast, and we need scale and we need speed to make that happen. And if we're all working together on the same plan, we can make that happen. But we need somebody who can show us how to do it, and that's what we challenged Rob to do through the Whittle Lab.
So that's your cue, Rob. Can you talk through a little bit about, well, I think maybe if you could start off with why? Why did we have the Aviation Impact Accelerator? You know, what were we trying to, what was the problem we were trying to solve in terms of like just responding to John's challenge, but then say how what we've been able to do in the last 2 years?
So I think one element of the why, I mean, it is unlocking change, and speed is key to this. And in a complex whole system problem, unlocking change is difficult. But the other thing to do, that the Prince of Wales at that meeting challenged us to do, was to stop talking within the community. Because one of the key unlocks here is to get, I heard at a talk earlier today from Alaska Airways that their passengers know more about recycling the plastic cups than they do about the technology of how to decarbonise the planes. And unless we get the public involved in this debate and more knowledgeable, they are the people who are going to be able to pressurise government to make the change. Yeah. But I'll show you a little bit about the model, a sneak preview. So when the model is launched, this will be the front page that you'll see. So it's evidence-based, its whole system, and it's an interactive experience. There's a button that says Simulate Journey. Now, the whole system model has 4 elements to it. So the inputs to the model are resources. So land use, electricity, water are coming in. Then the model has to simulate the fuel production route, building the plants, the technology readiness levels, the cost of those plants. It then has to work on the distribution network to distribute the fuels in and how they're going to work into the passenger journey, which is the experience of the passenger, which goes through the airport, but also then goes through the network of flights. It has to simulate the way aircraft networks work, and then the contrails, the climate forcing effects, and the effect of contrails. So this isn't well to wake. This is sort of resource to climate, the model works. So any model needs to be based on solid data, and we've had these technology questionnaires with the World Economic Forum, and they've gone out, about 80 of them, to small and large companies. And these technology questionnaires, the companies, the deep technologists in these companies say what they think the value of each of the technologies are at now, 2035 and 2050. And then they give an estimate of the uncertainty, because it's critical that we track uncertainty into the future, and then their confidence in their answer. And that gives us an immensely powerful data set from deep technology network from inside small and large companies. And then to build the model, we've had groups from across Cambridge and other universities like University College London and Melbourne. And the teams we've put together have to be in business, economics, policy, human behavior, as well as in the technology elements and the fuel production. You can see in the partners there, we've got, for instance, MathsWorks on the modeling for the user experience. And then the industrial partners in the program are critical. These aren't people you meet once every 3 months. These are deep technologists within the company who can really dig into the model and make sure it's realistic, because the technical constraints on flight are very tight. A load of technologies don't make a plane, and so your model has to be very robust under the surface. I'm not expecting you to read this, but what I'm trying to show here is the breadth of knowledge in the model. So you can see on the left, it says on the ground, and on the right, it says in flight. And each of these columns are different elements, such as the climate impact of making the fuel, the climate impact of the aircraft manufacture, the climate impact of the NOx that's produced in flight. And if you look across the top row, that's fossil fuel, that's the baseline case. And there's a large circle and a small circle. And the large circle is the maximum, and the small circle is the minimum, and that gives an idea of uncertainty in the problem. And then going down the page, we have many routes in the model of biofuels. We have power to liquids, where you're actually using electrolysis, and you're taking your carbon from the air and making your fuel. We have hydrogen and battery electric. And for each of them, we colour them according to whether they're better or worse than the baseline. So if you look at the final row where it says total, that green shows that it's better. But the key thing there is you can see the level of uncertainty in most of those routes. Now, that's the greenhouse gas effects, but I'm going to add on the contrails, the total climate forcing. And this is where things get really uncertain. You can see the size of that effect. And that shows that we have to be very careful with the routes we choose when we're comparing them to recognize that uncertainty in what we deliver. Okay, let's get on with a demonstration of the model. So this is what you'll see when you go onto the web page. And I've put in here a flight from Washington to Glasgow. And it's a bit like Google Flights or kayak.com, except you put in the year you want to fly. So this has got 2035. And I've chosen that because that's the year when we'll start to scale green hydrogen, where the SAFs will be coming heavily online, and where we start where Airbus have the first hydrogen aircraft in service, so they say. And in the model, I've selected climate impact. So the model's going to optimize for climate impact. Now, you can just say solve there, or you can go into the background and you can choose all sorts of things. You can choose the technologies you put on your plane. You can choose the different types of plane you fly. You can choose how many airports across the world you want to optimize over. You can choose the types of fuels, where you get your electricity from, and most importantly, in a way, where you get your source of biomass from if you're going for a biofuel. Okay, so let's do a solution on that. So these 4 solutions at the bottom, at the bottom we have a baseline model, which is kerosene. And you'll see on the kerosene, it's climate impact and its resource. So the resource is what we're putting in, and the climate impact is the output. Now, the kerosene, you'll see, produces 747 kilograms of CO2 on that one flight. And if you know your numbers, you'll know today that an aircraft on that route would be around 1,000. So the reason that's dropped to 750 is the technologies which the companies are developing at the moment will make the kerosene aircraft better by about 25%. If we start at the top with the models, the first model is a power-to-liquid model. So this is where we do electrolysis. We pull carbon with direct air capture out of the air, and we use the Fischer-Tropsch process to make a switch-in fuel. And that fuel goes into the aircraft that exists. And you see that has a very low CO2 output, but it has quite a high contrail effect. Below it, we have green hydrogen, which is similar, and blue hydrogen. And then if we look at the right, you can see the electricity use from the two. And the big difference here is if you look at the top two, the power to liquid and the green hydrogen solutions, they're using 3,000 kilowatt hours per passenger and 2,400 kilowatt hours per passenger. Now, what that's saying, if you scale that to the world's current flight, that's saying you would need 40% more electricity in the world to make these fuels. So these numbers are important because it's incredibly large amounts of electricity. So finally, I'm going to look at two of these cases. So I'm going to zoom in on the power to liquid and the green hydrogen solution. And now what you'll notice is above the blue yellow bars and below, you'll see dashed lines. And that is the uncertainty being tracked through the model in every single component. So we've got those uncertainties from the companies. And what's important here is you'll see the massive uncertainty in both the power to liquid solution and the hydrogen solution. And if you dig in the model into those two, in the power to liquid solution, the uncertainty lies in the direct air capture. That's where the risk is. And if you look at the green hydrogen solution, the uncertainty lies in the aircraft and the development of that aircraft. So you see the uncertainty in completely different places, but you can monitor it through the solution. So that gives you an idea of the model. The model, we think, will empower both sort of, clever young school children around the world to start engaging with and learning about the problem. But it'll also be a tool that policymakers or people in industry can see themselves through. So we hope over the years that people can add their parts to the model, and that will really enable us to see pathways which allow us, as John says, to accelerate change.
Thank you, Rob. Well, without too much further ado, I wanted to open the floor to questions and to see if people had things that they wanted to understand, either about the model or about the challenge. I mean, I think it's been, we've called it the Aviation Impact Accelerator because I think, as you've heard, we have this powerful need to accelerate action, to accelerate the pace of change. And I think our learning from engaging with different parts of business, with government and elsewhere, is that the more we can create a common evidence base, a common framework so people can understand the impact of their actions, the more that they'll be able to unlock and support that conversation. And even in that process, I think we've been discovering interesting things about the different evidence bases that people have, and what that means in terms of different assumptions. So, are people being more optimistic or less optimistic about different technology curves? So it's been a really valuable process. But I'd love to sort of see if there are any questions in the room or any questions virtually that people would like to ask. So, okay, I've got one there and one there. If you'd like to go up to the mic and ask a question.
Yeah, hi. Just a question about the model, because I didn't see any kind of land use for kerosene. If you would pull back your model, please, like 2 slides back. I was wondering, there's no land use for fossil fuels, and that's simply astonishing, isn't it?
You mean on...
The slide before.
Yeah, sorry, I've gone past it.
That one.
Yeah, so
Kerosene direct land use 0. Frankly, I don't believe that.
There will be a small number there.
Yeah.
That bar gets a lot larger when you go into the biofuels or you go into a power-to-liquid solution that requires. But you're absolutely right. There is a number there, but it's a small number. You're right.
Thanks.
Yeah.
Hi. So I was wondering, until it gets completely decarbonized, what other measures can be taken to reduce the footprint of aviation?
So just let me check I heard that correctly. You're saying if aviation is completely decarbonised, what other measures could be taken, or isn't completely decarbonised?
Until it gets decarbonized.
Okay.
What measures?
Yeah. So maybe we could take, I think both panellists will have good answers to that question, or will have some thoughts about that question. Maybe we take one more question and then just...
Yeah, thank you very much. I'm struggling a bit with the concept of uncertainty in your modeling. I think it's a great tool, but there are many different kinds of uncertainty. So, of course, you have uncertainty in technology advancement. What will be the technology level of aircraft in 2035 and of SAF production, etc. And then you have other things, especially regarding the non-CO2, the contrails. So there's uncertainty because there's growing but still not perfect knowledge about the climate effect of contrails or other non-CO2. There's also uncertainty about the weather conditions. Is there humidity in the air that creates contrails or not? So that can vary from one day to the other. And there will be hopefully methods to avoid contrail formation, which by 2035 is probably possible. So can you separate these different kinds of uncertainty? Thank you.
So, John, maybe if I could start with you, particularly with that question about what can we do now while we're waiting for these different answers to arrive. But also, you might not have an answer in terms of the like how to resolve the uncertainty, but it'd be interesting to hear your thoughts in terms of what are the uncertainties that are most challenging for the business as they're trying to engage us in that.
So what can we do? Well, we can all choose not to fly, and we can all make our personal choices about that. We can choose to buy sustainable aviation fuels for the flight that we are going on. An increasing number of airlines do that. We offer it also through the airport, but BA, Lufthansa, many others are starting to do that. You can offset if that's what you prefer to do. So those are personal choices that people can make, and the industry is increasingly making those available to you. And paying the premium for sustainable aviation fuels is something we're encouraging companies to do, because they all have Scope 3 emissions targets, and this is a way in which they can help to meet those Scope 3 emissions targets. And what that does is to create demand for an increased supply of sustainable aviation fuels, which helps to scale up supply, because that's one of the biggest issues we have. There are some other things that are happening, and Rob alluded to some of them. The changes in the aircraft technologies, changes to airspace, those will all help to reduce the carbon emissions from aviation. And just airspace change alone could reduce the carbon footprint of aviation by around 8%. So it's something you might not tend to think about, but it can have a material impact on the emissions of the sector. But we need to change fundamentally, we need to change the fuels that are being used to power the planes. And if I can just pick up on uncertainty, one of the things I really liked about this is that it's not just about, it's actually a decision-making tool for businesses. Which of these technologies should I be investing in? What are some of the challenges I need to overcome? And I think one of the things that that you've flagged here is the impact of contrails and NOx, which very little is known about at the moment. We do tend to focus on carbon because that's the elephant in the room, but we don't understand those well enough. And we need to understand them better, and you've highlighted just how important that is. And we need to see what we can do about them, because we haven't turned our minds to those at all yet. But we clearly need to, because as you've shown, there's no point changing the fuel on the plane if you haven't really tackled the overall environmental impact. So this helps to show where the focus now needs to be, as well as choosing which of the technologies are going to be the most sustainable for us to use.
Rob, over to you for both questions.
Yeah, if I can answer both questions. So the first question, I think it's really interesting because this attraction to shiny big solutions, which we all like, especially aviation engineers like shiny big solutions. You know, if you know the success that British cycling has had on the track, it's come from the sum of incremental gains. And the model, actually, we hadn't realized it at the start, but those incremental gains could be changes in airport operation. They can be changes in the way we land aircraft. They can be changes in air traffic control. And understanding how a sum of incremental gains could come to a reasonably big number at a much shorter time scale than those bigger things, doesn't mean we don't do the bigger things, is really critical. So actually, the model to give an arrow to people about the way individuals can act in their small way to make a bigger change, I think I hadn't realized at the time, but has been incredibly powerful. On the uncertainty front, I think you're spot on. One of the biggest problems we've had to deal with is different types of uncertainty and how you deal with those types of uncertainty. And there's one type you didn't mention, and I didn't see coming at all. We spent a lot of time on thinking about uncertainty, but one was when we collected all the results from the data sheets can be bi or trimodal. In other words, there are communities who believe different things. And those communities, sometimes when you dig into them, are justified. So, for instance, if you ask the large OEMs about battery electric flight, they will tell you one thing. And if you ask the new entrants into the field, they will ask a different thing. And the way you deal with that level of uncertainty or difference between means within the model can tell you very different solutions. So just finally, the contrail one's an interesting one. So in our model, we have a full global airspace map of humidity and altitude. And literally, the planes fly the routes, and you put the date in, and it tells you probabilistically how the contrails will form on those routes using the best model that exists, the COKIT model from DLR. So that's as accurate as you can get at the moment. And we have actually tried now flying different altitudes, different patterns, contrail avoidance. So you can start to put these realities into the model. You'll see Satavi as one of the partners in this. And we can start to look at moving things from uncertainty to certainty in the model by bringing in those extra realities. And I think that's critical. But you've spotted it's a real challenge.
So I can see many, many more questions in the room, but I can also see a great big stopwatch in front of me, which sort of says that we're going to have to close. So maybe I could just, if we can get one very quick question from over there, and then other people will be very happy to talk afterwards. But.
Thank you. So first of all, thanks to the panelists for this great introduction. My question is concerning what your vision is to really go to net zero. So on the previous slide, you showed us what other fuels how they might help us in reducing emissions. Now, if you want to go to net zero, there's definitely some way to go still. And what are your thoughts on how we would be able to achieve that in the future, whether it's other technology or it's carbon removal? And I'd be very happy to hear about that. Thank you.
It's a great question to finish on, so John.
So it depends on your timescale. For 2050, the only way we can get to net zero is through, the bulk of that will come through sustainable aviation fuels. Electric and hydrogen and airspace change and all the other things we need to do will make a material contribution, but they won't be enough to get us there. The main reason for that is that you need to change the planes themselves, some of which haven't been developed yet, to get a hydrogen or electric fleet. By 2070, that may have changed completely. And by 2070, we may be at absolute zero for aviation. But for 2050, we've got to have our eyes on the prize, and SAF will be the solution because it can be blended in current planes with kerosene, and that makes it enormously flexible. But what Rob's work has helped us to do is to identify none of this is easy, and we need to make sure we're choosing the right solution that doesn't create other problems elsewhere. And I think in this policy-making phase of our journey to net zero, it's the right time to have the kind of work that Rob has done to help us to make sure we're going down the right path, and we don't then regret it in 10 years' time after having spent billions of pounds in decarbonisation.
Thank you.
A very quick answer. So I think the Prince of Wales puts this very well. You know, we should treat this like a war. You know, post-war, we developed the first jet airliner, the Comet, in 4 years. The engine, the aircraft, everything that went with it. We really need, on SAFs and on other technologies, we need a gear change in the rate at which we develop these technologies. The key thing is, though, we could spend a lot of money and we could make the problem worse. So we have to monitor, as I said, uncertainties through the problem, and we need to hone down those uncertainties to make sure where we're pointing at is actually going to solve the problem.
Yeah.
Ladies and gentlemen, thank you very much for being a great audience and for some wonderful questions and for bearing with us through this session. We've been very pleased to tell you about our model, and we look forward to continuing to engage and work with you on it. Thank you very much.
Thank you.
Thank you for attending. The event is now over. Please vacate the Action Hub so our team can clean the room.